Lights, camera, action potential. Today, using circles, pipe cleaners, and beads, we will show you a breakdown of the process of action potential. The purple circles represent acetylcholine. The brown circles represent acetylcholine esterase. Purple pipe cleaners represent acetylcholine-gated sodium channels. Yellow beads represent calcium ions. Orange beads represent potassium ions. Pink beads represent sodium ions. Gold pipe cleaners are voltage-gated calcium channels. The red pipe cleaners represent voltage-gated potassium channels, and the pink pipe cleaners represent voltage-gated sodium channels. Now let's get started. A large number of voltage-gated ion channels are found in the cell membranes of neurons, which allow for the movement of potassium ions, sodium ions, and calcium ions into and out from the cell during an action potential. When a stimulus depolarizes the membrane to the minimum threshold of activation, voltage-gated sodium channels are the first ion channels to open. As sodium channels open, some sodium ions rapidly enter into the cell. Voltage-gated potassium channels open in response to depolarization caused by sodium influx. The movement of potassium ions out from the cell repolarizes the membrane back to its negative resting potential. In the neuron, voltage-gated calcium channels are only found in presynaptic terminals. Activation of voltage-gated calcium channels allows the movement of calcium into the cell. Calcium entry triggers the release of stored acetylcholine from vesicles in the presynaptic cell. A synapse consists of the presynaptic terminal of one cell as opposed to the postsynaptic membrane of the next cell. The small gap between these terminals is called the synaptic cleft. Acetylcholine is released from the presynaptic terminal, then binds to and activates acetylcholine-gated sodium channels, which allows for sodium entry into the postsynaptic membrane. Acetylcholine is rapidly degraded and inactivated by acetylcholine esterase in the synapse.